I'd like to talk a little bit about integrals that involve inverse trig functions. Before we talk about integrals, I want you to pause the video and see if you can figure out these derivatives. Okay, so hopefully you looked back at your notes and you found these. So the derivative of inverse sine x is going to be 1 over the square root of 1 minus x squared. For number 2, keep in mind that arctan is the same as inverse tangent. There's a chance that you will see it both ways, so I'm going to give you examples where we see both ways. That's going to be 1 plus x squared. And then the derivative of inverse cosine of x is negative 1 over 1 minus x squared. I do want you to notice that 1 and 3 are almost the same thing, but just different by a sign. That's going to actually really help us because that's going to mean that we have one less thing to memorize when we talk about integrals. So these are the two inverse trig formulas that we have. You might notice, I did mention this just a second ago, that cosine and sine inverse cosine, inverse sine are almost the same thing. So like if you get something, you don't need to write this down, but just kind of keep it in your mind. If you get something like this, technically that is the same thing as inverse cosine, but rather than trying to evaluate it as inverse cosine, just pull the negative out front, and you will get an answer of negative arc sine or negative inverse sine. So just remember these two things. You might see the formulas for these things written slightly differently. You might see them written with an A. I will show you that at the end of the video, but I think that you probably will do better if you just do it the way that I'm going to show you now. So I'm going to show you what I think is the easiest way to do these problems with the most minimal amount of memorization possible, because there's a lot of things that people miss when they do these types of problems. It's rare that you see a problem that is just like the integral of dx over square root of 1 minus x squared, and then you write inverse sine of x plus c. Most of the time you will have to use u substitution. And that is going to happen for almost every single one of these problems that you see. So I'm going to give you a few steps that will help you when you're doing u substitution, and then we'll do some examples. So these are the steps that you're probably going to want to use when you're doing u substitution. As you're doing the problems for this, I would just like cross-reference these steps. And so the first thing you're going to always do is look to see what the integral most looks like. You're going to want to get the constant to be 1, and by constant I mean whatever this thing is right here. The other thing it says is write the x part as something in parentheses squared. The x part, I mean this thing right here. So, and it's the same for the sign. And then you're going to use u substitution and integrate. So for my first example, I have the integral of 1 over the square root of 1 minus 4x squared. If it makes it easier, you'll notice that I mentioned 1 over this. If it makes it easier, feel free to write it like this. I think that sometimes people look at that dx on the top and in the original formula and they get confused about it. So the first thing I want you to notice is this looks like looks like the first formula, the inverse sine formula. The second step is to get to the constant to be 1. This one is already 1, so we're not going to change that. The next step is to write the x part as something in parentheses squared. So this part right here, we need to write that as something squared. And we are not going to just write it as 4x squared. What we want is we want something here squared, and you need something in parentheses there. So be careful about not doing 4. It's actually going to be 2x squared. You want it to be equivalent to what you started with. And so I almost forgot my dx, don't forget that. So then we're gonna write it like this. Now I'm going to u substitute. And if I use u substitution, I would like to substitute in for whatever that x term is. When you're using inverse trig type stuff, if you recognize that something is an inverse trig thing, and you know you need to use substitute, it's pretty much always going to be for whatever this term is here. So hopefully that'll help you know what you need to use for u substitution. So I have u equals 2x. That gives me du equals 2dx, or du over 2 is equal to dx. Now if I substitute that into the original equation, I end up getting 1 over the square root of 1 minus u squared times du over 2. That du over 2, you can pull that 1/2 out front. So I now get this right here. You'll notice that that looks really, really similar. In fact, almost the exact same thing as what I have for my inverse sine. So I'm going to write this as 1/2 times inverse sine of u plus c. My final answer is just going to be this written with u equals 2x. And that's going to be my answer right there. So I will tell you the number one mistake I get on this thing is I have people putting inverse sine of 4x. Make sure that whatever is in your parentheses there is whatever you square to get that, that x squared term. For my second problem, you'll notice this looks similar to the inverse tangent integral. I am going to pull that 3 out front first. It'll make my problem a little bit easier to deal with. There is one little thing about this that I think is a little confusing, and that's that 16. So there really are two ways to do it. However, I want to show you the way that involves the least amount of formula memorization. You might think this is really tricky, so I will show you the formulas in the end. But I'm hoping this is like this is a little bit easier to understand than just plugging in numbers. So what I'm going to do is if you look at the steps that I had on the previous page, the first step was, well, first of all, you need to recognize that it's inverse tangent. The second step was to get the constant to be 1. Right now, my constant is 16, so that's obviously not 1. What I am going to do for this, in order to get that constant to be 1, is I am going to factor out a 16 from this denominator. So I end up getting 1 plus, now if I factor out a 16, it's the same as dividing by 16, so I get 1 plus x squared over 16. I forgot my dx again. That's actually a really common thing that people do. Honestly, if you are just working a problem out in your notes and you forget the dx, it's not a big deal. Don't do that on a test. Definitely don't do it on an AP exam, because you probably will get docked points for that. The dx tells us what variable we're taking the integral with respect to. Right now, it doesn't really. It's not a really big deal, but when you get into further calculus classes, you often have multiple variables, so it's really important to have it then. Sorry, that was a little, went off on a little tangent, no pun intended. Okay, so now let's look at what we got so far. So that 16 on the bottom, I am going to pull out front. It's going to stay on the bottom of my fraction. It's 1 over 16. Now I have 1 over 1 plus x squared over 16 dx. So now I've gotten the constant equal to 1. The next step I need to do is I need the x part of this expression to be in parentheses squared. So in order to do that, I need to figure out x squared over 16 is what squared? And that's actually going to be x to the 4th squared. Occasionally you will have something where you get a radical in the parentheses there. It's not pleasant when that happens, but it does happen sometimes. When you're first starting out though, most of the numbers are nice, but just know that sometimes you will get a radical in there. Okay, so now I have that. Now I'm going to use u substitution. And I'm going to do u equals x over 4. when I take the integral of that, I get du is equal to 1/4 dx, which gives me 4 du is equal to dx. So then now I can rewrite this. The 3/16 is still going to stay up front. I get 1/1 plus u squared times 4 du. And if I simplify that out, I end up getting 3/4 in front of my integrals. The 4 and the 16 can simplify out. Over times the integral of 1/1 plus u squared du. That gives me 3/4 inverse tangent of u plus c. And if I replace that u with what I originally had, I had u equals x over 4, so it's going to be 3/4 times inverse tangent of x over 4 plus c. So we're going to do one more example. It incorporates both of the things that you did in the previous two examples. And you're welcome to pause and try it on your own, or you can just let me go through it. So this one, again, I always like to write it as like 1 over something. For me, it's just easier to look at. This, I want you to notice, looks like the same setup as an arctangent or inverse tangent. First thing that we need to do is make that 9 so that it becomes a 1. And we're going to do that by factoring out a 9. Sometimes you will have a nice number that factors out really nicely, like something divisible by 9 on the other with the x term, but that didn't happen in this case, unfortunately. So you're going to get 1 plus 25 divided by 9x squared on the bottom. I'm going to pull that 1/9 out front. The other thing I'm going to do on this step is I'm going to figure out what squared gives me 25/9 x squared. I end up getting 5 over 3 times x. If I square that, I get back to what I previously had. So now I can use u substitution, and I end up getting du is equal to 5/3 dx, which gives me 3/5 du is equal to dx. So now I'm going to plug that into the equation. I end up getting 1/1 plus u squared times 3/5 du. If I pull that 3/5 out front, I end up now having 1/15 times the integral of 1/1 plus u squared du. That is an arctangent, and I end up getting 1/15 inverse tan or arctan of 5/3 x. I plugged the u back in plus c.